Am I audible, Ramya? Ramya? Okay, thank you. We will wait for 3 to 4 minutes so that others can join. Okay, let's move on. Let's start. So yesterday we were talking about the test of hypothesis, right? So let me show you how this works. Okay. Uh, there are two methods when it comes to the decision making. Critical value method. Second, p-value method. These are the two methods. Yesterday we discussed about this. We came to know about the steps over here. Let me show you what the steps are. If I go to this one, this is your critical value method. Okay. Oh, sorry. Here yesterday I said x minus mu. This is x bar. X bar by x bar minus mu. Okay. I apologize. Okay. Let us go back and revisit the whole thing. So now again I am taking Pepsi Coca-Cola example. So now I practically will show you how to do this method. So I need to collect the sample, right? So there are few people, there are three roles which we discussed yesterday. Okay. Based on that, we arrived at our null hypothesis and alternate hypothesis. That's what we did yesterday, right? Fair enough? Any issue there? Okay. Now, from a consumer viewpoint of view, what will be the my H1? What is the consumer want as a consumer? What is that I wanted to prove? I wanted to prove the volume of the Coca-Cola drink is less than 200 ml. So what is my H naught? Opposite to this, right? This is greater than or equal to 200 ml. So let us, based on the claim means H1, based on the claim done by the consumer is going to collect the data. When he collects the data, he will be collecting the data in favor of him, right? So I'm going to simulate the data using Minitab. Okay, just going into Minitab. Where is Minitab? Yeah. Okay, I'm just simulating the data. This data I will take it over there. Calculate random data. Go. I'm generating a normal data. Normal data means n is greater than 30. So that means, for example, I am taking it as 100. My n is 100. Store it in C1. Here in the storage C1. My average mean is 200 ml. There is a variation of 10. The standard deviation is 10. Yep, the data got generated here. Okay. Now I'm copying this data into my Excel. This is only for data generation, friends. Okay, you don't need to worry about what is happening over here. Okay, so here I'm pasting the data. Yes, data is now available. This is Coke data. Okay. If if you closely observe, sometimes it is 191, sometimes it is 201, sometimes it is even 221 also. So there is a variation that is happening with respect to the volume of the data that you have collected as a consumer. Okay. So what is the first steps that we have defined here earlier in the critical value method? What the steps is, first thing, frame the test of hypothesis. That is what we did just now. What is that we framed it? Mu is less than 200 ml is my H1 and mu greater than or equal to is my H0. This is the test of hypothesis. Now I am going to define an alpha and collecting the data. Okay, go back here. Second step. What is alpha? By default, nothing has given, so I'm taking it as 5%. Now here is the situation. A couple of things you need to remember always. Always, very, very important. Whether I am doing the lower side test or one side test or two side test, okay, how do I know? You will be knowing this based on H1. Type of test is always decided by the based upon your H1, because here H1 is less than 200 ml. That means when I plot a histogram here, so let me go back into my Minitab. I am going to create a histogram here. I'm selecting the histogram. Yes. C1. Scale is fine. Label data. Oh, that's all fine. Okay. Look at it. See here. This is the histogram. Let me regenerate the histogram. I'm regenerating the graph. Histogram. I want this graph. So this is the picture. Okay. This picture okay, friends, this is the picture. So now in this picture, this is your volume of the data, volume of the drink. Okay, based upon the frequency that you have collected, that means based upon the values that you have here in this Excel, here the same data. Okay, that is here. So this is how your curve is looking like now, your histogram. Now based upon H1, I will be deciding what kind of a test it is. What is my H1? My H1 says this is mu is less than 200 ml, right? This center 200 is here, sitting here. You see here, this is your 200. So your mu is less than, that means it is toward this. So H1 is talking about toward this, and at the same time, your alpha is equal to 5%. That means this is one side test, also called as lower side test. Lower in the sense lower side of the mean value. So what is my alpha? Alpha is nothing but my significance level, also called as confidence level. Significance level, also called as confidence level. Both are same. So that means somewhere here, if I look at this, if you go towards the minus infinity and here towards the plus infinity, this curve never made this graph. It goes like this. Okay. So your alpha is somewhere here. This is your alpha, 5%. So this shaded region is alpha. This one, this area, the rest of the area is your acceptance region. This is called acceptance region. Acceptance of what? Acceptance of H naught. H naught is nothing but null hypothesis. This one is your rejected region of H naught. Guys, friends, are you with me? Any question here? No question, right? Shall I move on? Please respond. Concept is clear in your mind, right? Any question? Because before I move on to this one, this clarity has to be there for you. Perfect. Moving on. Okay. Now, now what I have to do is given my alpha, which is 5%, can you tell me what is the Z value from the tables? Can anyone of you open from the tables and can tell me what is the Z value? You like it or not, this is 1.96. I know the number. You remember? For 95% confidence level, Z is plus or minus. We remember this, right? 95%, 95%, 99% of the confidence level. What is the G value? I talked about this. This is plus or minus 1.64. This is plus or minus 1.96. This is plus or minus 2.58 something. Remember? I told you, you have to remember these values. Not necessarily every time you have to go and open the table, G table and see it. Okay. So since it is one-sided test, because your H1 is saying that it is one-sided test, so you will be taking the G value as minus 1.96 because it is a lower side test. If it is a higher side test, that means your alpha will be standing here in this area. Okay, then your Z value will become plus 1.6. But right now, from the context of our problem, it is 1.96. Okay, now what you have to do is, after this you have to calculate Z calculated. There is a G calculate. How do I do that? X bar minus mu divided by your S by square root of n. What is X bar? What is the X bar? X bar is the mean value of your data. I'm going back into my mini tab. See here, What is the mean? Mean is 199.9. That means if you come here, see here, if I want to select this, mean is nothing but my average of this data. Very simple. How much it is? 199.9. Okay. So don't get confused about this. So your X bar here is 199.9. That means this is 199.9. What is my mu? Mu you have to take it from your test of hypothesis. What is the test of hypothesis talking about? Test of hypothesis talking from this, you have to take it from H naught. That is minimum 200. This is 200 divided by standard deviation by n. N is total 100 data points I have. So square root of 100 is here. What is the standard deviation here? Again, I can go and get it from either Excel or from my Minitab. Minitab, you see standard deviation here 10.19. Did you see here? 10.19. So I'm coming here. I am saying this is 10.19. Can any one of you calculate this value and tell me what is the value? This is minus 0.1 divided by 10.19 by square root of 100. So this is 10.19 multiplied by square root of 100. How much is this? This is what it is. Now 0.1 divided by this value. It is 0.009. Right? So which is close to 0.001 if I round it up. Friends, are you with me? Oh, sorry, this is not right. I did a mistake. That's what I was thinking. How come probability is going to be 0? This is divided by. Okay. Yeah, correct now. Now this is 0.98. Okay. So this is 0.098 minus. This is your Z calculated. Okay, friends. Now, let me draw the picture. Same picture. Okay, the same picture. So your mu is sitting here. This is your mu, and we are on to the left hand side of it because we are looking at the lower side. Your alpha was somewhere here. Okay, this is for 5% of the alpha. This value, this is called lower value. What is the lower value? Lower value of G. What is the lower value of G? For alpha is equal to this. for alpha is equal to 5%, this value is going to be minus 1.96. See guys, in this picture, you have the values not converted into Z, but whereas I am talking about this one converted into 1.96. So, because in the graph we have not converted that into Z, I always say, okay, I draw the picture like this. This is your picture. The same mu values which you have seen, okay, I'm translated this into Z value, okay. This is the center, your mu, or you can say G equal to 0. This is at the center. From here, you move toward this direction, or you move toward this direction. Okay. So, here, this is what your alpha is. Alpha is referring to your minus 1.96. This zone is alpha zone. This is the rejected zone. How did you get this? Using the alpha, you went and find out the G value. This is the G value. Now G calculated, which you calculated right now, is minus 0.098. This is G cal. So where is this G cal is falling from center? This is before this minus 1.96. That means you are falling somewhere here. This value, this G value is minus 0.098. That means this is what? This entire thing is a fail to reject region of H0, which you call it as acceptance region. This is fail to reject. Fail to reject region of H0. That means it is an acceptance part. So whatever your G which you calculated right now, G calculated is falling in the accepted region. That means you are accepting H0. What is H0? What is H0? H0 said your mu is greater than or equal to 200. Though you claim that your mu is less than 200 ml, that means though you claim that you have received less than 200 ml, but after the data collection, when you did this whole process, now it is proved that what you said is not right. Volume of the coke is more than 200. So what you have done is, for any sample, you have a sample. From the sample, how do you collect the data from the sample? Data collection. First, what you did, you collected the data and you created a sample. And from the samples, you are trying to estimate your population data. Based on the population data, you want to make a decision. Decision making has to happen. Okay. Decision making, when decision making wants to happen, then from the sample, using your central limit theorem, you translated the information into G values. Okay. From the G values, you went toward the test of hypothesis. What? Based on the G values, you are able to try to predict what will be my population mean. What is my mu here? That's what your objective is. Once you created this mu, you are able to figure out to define the mu in terms of range or a point estimate, whatever that is. Now you wanted to take a assumption that whatever the mu value which you have created or which you have calculated using the sample is right or wrong, or is it, rather, instead of saying right or wrong, is it acceptable or not? Okay. Based on that, based on this process, you will be able to figure out the decision making. That means this is right. That means whatever the mu that you have created or whatever the decision, whatever the claim that you are making, this claim is H1. This is against to the claim of H1. Claim is always H1. Okay. Accordingly, you make the decision. Okay. So this is how you actually estimate your population parameters from sample. This is the process. Because it is onto the lower side, okay. So here in the above example, I did not convert them, the mu value, I did not convert the x bar values in your mu values or x bar values into z, okay. But actually here the process is you will be converting it. You don't need to draw that particular, the top graph. All you need to do, you need to draw this kind of a graph, and then you can make the decision. Any questions? Is it clear now? Let me execute the same example once again, but with a different view. Example 2. Now I am taking production engineer view. What is the production engineer's view? What is his H0 and what is his H1? Simple, right? H1, he always says that his mu is not equal to 200. That is what his claim. That means this is 200. When production engineer is trying to prove this, this is his claim. He is claiming this. This is his claim. When he is trying to claim this, so he will obviously produce the data accordingly. He will go and collect the data accordingly. Let us go and simulate the data again, once again in Minitab. Okay, I'm going into Minitab. Now I'm generating another data. Okay, so cal, go to random data, normal data, save 100. Instead of this, it was C3. Okay, when he collects the data, same mean will be somewhere, let's say it might be 190, and the standard deviation could be 10, or maybe let's say 7. Whatever. See, this you do not know in real world. In real world, you are actually collecting the data. To make you understand, I am simulating the data in this Minitab tool so that we will have a good understanding about the concept. Keep this in mind. Otherwise, don't think that, okay, oh, I need to learn Minitab for this again on top of so much of subject and all the stuff. Don't need to bother about it. Okay. For this data, let me go and calculate. See here, mean here is 189.79. For this, your X bar is 189 point, how much? 79. What about standard deviation? 5.84. So your standard deviation S or sigma, both whatever it is, because we are from a central limit theorem, we are taking your population sigma is nothing but your sample sigma. I am taking this as 5.84. N number of records is 100. Right? Now, what will be my G table? G table is coming from your alpha. What is alpha here? 5%. But what is your H1 is talking about? What is your H1? H1 is this. So what kind of a type of test it is right now? Because it is not equal to 200, I need to draw the graph. Draw the histogram. When I draw the histogram, your mu is somewhere in the center. So it is not equal to 200. That means either it may be less or it may be right. It may be more. Either it may be less or it may be more. So your region, rejected region is going to fall on both the sides. This is called two-sided test. What is this two-sided test? How did you come to know about this? From your H1. Okay, whether it is greater than or less than, when the H1 is greater than or less than, then it becomes one-sided test. Either it is the lower side or it is upper side. When it is the right hand side, it is upper side. When it is the left hand side, it is lower side. Now what happens here? Two-sided test. That means your rejected region is sitting here on both the sides. That means this is the rejected region of H0. This is also rejected region of H0. The in between is the one which is a acceptance region, which you call it as fail to reject. This is your, fail to reject H0. That means acceptance. Now, what is the alpha here? Alpha you have taken 5%. Because it's a two-tailed test, you have this side it is alpha by 2. This side also it is alpha by 2. That means when alpha is 0.05, alpha by 2 is going to be 0.025. Let us go to the G tables. Where are my G tables, buddies? Where is in my laptop? Okay. Templates, I think. Yeah. Okay. See here Z. 0.025. That means 0.2 and 0.5. This is what you have to look at it, right? How do you look into the Z values? How did we arrive at these values? How did we calculate our Z values? You need, hold on. This is something which again we have calculated over here. Okay, we have calculated this. When my confidence level, when the significance level is 95%, Z values we have already calculated this as plus or minus 1.96. This is given plus or minus 1.6. So you don't need to really go back and look into this G values once again. Okay, I'm using the same 1.96. Now since this 1.96 is plus or minus, because the test is two-sided, both the sides, that means both the sides, that means this is my minus 1.6, which is called ZL. That means lower side of the G. This is my upper side, which is called Z upper. Okay. So in between is you need to calculate your G cal. How do I calculate my G cal? Use the same formula. What is this? X bar minus mu divided by my S sigma root n. So your X bar is 189.79 minus 200 divided by this value 5.84 divided by square root of 100. Let us calculate this value. What is this value? No. What is this one? Below one, 5.84. 5.84 divided by square root of 100 is this. And this one, 189.79. 189.79 minus 200. How much? 10.25. Okay. So value will be 10.25 divided by this one is how much it is? What is this? This is not the right one. This is this value divided, sorry, yeah, this value divided by this value. This is 17 point something. Yeah, minus 17 point something. So where is my your G cal? This is coming up to minus 17 point, let's say something. So where is this is going to fall? This value minus 17.9 is going to fall somewhere here. Somewhere here. That means if I extend this graph, it is falling. So where it is falling? It is falling in the rejected area. Friends, are you with me? It is falling in the rejected area. Rejecting of H0. Rejecting of the H0 means what? This is H0. That means it is not at all equal to 200. It is given. That means production engineer is what he is saying is correct. Guys, friends, are you with me? Friends, am I audible? Please respond. Okay. So this is called critical value method, guys. Are you with me? Okay. So there is another method called p-value method. It's also very simple method. Another decision making method is you don't need to remember all these things, okay? Because when you get into the code, you know what it will show you the values. But if you understand this concept, then you can actually contribute a lot from that perspective, and you can make the right inference for your data, for your problem solution. Okay. The very important second method is p-value method. P stands for probability. This is another method which is this is more popular, and industry wise people use p-value, people don't use z-value. Why is like that? There no specific reason, because they simply say that this make more relevant, this make more sense. Okay. But before entering into this p-value stuff, let me go back and talk a little more about the same thing. Say about the z values. Let me see. So your z is actually x bar minus mu by s by square root of n. Suppose Ramya is making chicken biryani. Sorry, Ramya, I'm just taking you as one of the for my example. I ask for your permission. Is that okay? Okay. So you are making the chicken biryani. So suppose you are using 1 kilo of chicken and some ingredients, fixed ingredients, all are fixed ingredients. So you prepared the biryani, let's say 10 times, 10 different times. Okay. Can you guarantee that every time you prepare all the 10 times, the taste is going to be the same? Ramya? No. Taste is not going to be the same. That means, okay, you look at this. X bar minus mu, this is the basically what you are doing is you are making the biryani, and this difference of this, if the value, let's say z value is 0.5, then this becomes x bar minus mu. Okay. So whatever the situation where you are same 1 kg you are putting every time, you are putting the same flame, you are putting the same ingredient, but still taste is not going to come as same. Why? Because there is some inherent process which is happening inside. That means that the taste is going to deviate every time she prepares the chicken biryani. What is the deviation? This is the deviation. This deviation is called as noise. She will not have any control over the noise because this noise is happening inherently by itself. No matter whatever you do, you can't control I mean, you can minimize this noise, but it will exist by default. So the difference between these two is actually factored by your noise. If it is 0.5 times of my noise, then it is acceptable. That means if I have my picture like this, so if it is closer to my mean, the taste value is closer to my mean, that means the taste is acceptable by Ramya and her relatives. If the taste is too going far away, that means x bar minus the difference between these x bar minus mu is more and larger. That means the taste is going completely out of control. So the people can say the biryani that Ramya prepared is not good. When is that good, not good comes in? When they have the certain limits over here. These are the limits which you are trying to figure out, ZC and ZL. Beyond this, it is not good. But within this is good. That is what it is. So we will be tomorrow on Monday onwards, we'll be talking more about this one, where we are jumping into a concept called ANOVA. Okay. Hope, guys, you will not find this kind of explanation in any textbook. This comes out of the experience, my dear friends. Hope this is clear. So the difference between these two, if it is very narrow, that means the difference is much smaller. That's where your predictability of the taste comes much better. That means every time she make the chicken biryani, people can figure out that it is Ramya who made this biryani, because that's the brand name. You might have seen this in your home, right? Your grandma or your mother, if they cook it, anybody who can just close eyes and they just eat that and they'll say, okay, your mom cooked it, your grandma cooked it, right? But the concept is this, my dear friend. This is again coming from this hypothesis. Test of hypothesis. What is the hypothesis? Hypothesis is nothing but an assumption, right? What is an assumption? Assumption which you are trying to say is you are claiming something and you are assuming something and you are trying to prove whether the assumption is actually right or wrong, or whether assumption is falling within the specified limits or not. That's what the hypothesis is all about. The test of hypothesis basically enable you to make the decision on what? Decision on the prediction of your population parameters using your sample is acceptable or not. That is what it is. Hope I made it clear to you all, guys. Okay. Now I'm moving on to p-value. P-value method. This is another method. Very popular. Popular mainly because p-value, really there is a wonderful algorithms written in Python and R for p-value. So people started using this and then it became very popular. The probability value. Critical method. Any questions, my dear friends? before I move on? Okay. In p-value, okay, it's very simple. What you do here, you say it is about probability of, let me write it down, probability of null hypothesis, that is your H naught, being accepted. Being accepted. Okay. In another words, the p-value, what is this? Is the smallest level of significance. Smallest level of significance that would lead to rejection of H naught. You guys remember this. It is the smallest level of significance. That means smallest level of your alpha that will lead to the rejection of H naught. Okay. Again, same fundamental, same thing. Whatever we are trying to do, we will also do the same thing over here. There is no different, but when it comes to the way you will be approaching, it slightly modifies, slightly changes. Are you with me? Okay. So let me take an example and talk about it. That way it will be more interesting, and then you will understand what this is all about. Okay. So what I am saying, you let me take an example of this. Here is a manufacturer. Okay. Here is a manufacturer. Here is a manufacturer. What he does, he produces, this manufacturer produces biscuits. This is a bakery guy. Okay. This biscuits, whatever, let's say Jeera biscuits, the life of, or rather say the life of this particular biscuit is, let's say, 36 days. Okay. And you love these Jeera biscuits. You kept on going to this bakery. Manufacturer is nothing but a bakery guy. You kept on going to this bakery, visiting the bakery. Whenever you visit the bakery, you eat these Jeera biscuits. But one fine day, you got a doubt, saying that this bakery guy is actually selling the biscuits whose lifespan is more than 36 days. So what you want? You wanted to find out this. So what you did, you collected the sample. Every day you were going there. So what you did, you decided to collect the what do you call, the sample for 49 times. You collected the samples. Every day you went there, you bought 100 grams or whatever it is, and you started testing what is the life of this. Is that okay? After collecting the entire data, now you have calculated average life of Jeera biscuits. Average life of Jeera biscuits. Your Jeera biscuits turned out to be 34.5 days. Guys, given the scenario, the deviation, your standard deviation, let us assume that the standard deviation set by the this guy, the bakery guy is 4 days. That means 4 days this way or 4 days that way, this is going to spoil, or Jeera biscuits are not usable before 34, I mean plus or minus 4 days to 36 days. Am I making clear? Is the problem statement is clear? Now here I am saying my take alpha as 3%. Now I'm taking my alpha as 3%. This is your business problem. In this context, now I want to solve the problem using p-value method. Almost same steps, little change here. Now let us look at your H1. What is your H1? Your H1, what you are trying to claim is, you wanted to prove that the lifespan is more or less. So mu is not equal to 36 days. This is what it is. So what is obviously my H naught? This becomes 36. That means again it is two-sided test. In case when you are using this p-value method, this is called two-tail test. One-tail test, two-tail test. When you are using the G test, you call it as one-side test or two-side test, lower side test or right side test. When it comes to the p-value method, you call it as one-tail test or two-tail test. Rest of the story is same again. Okay, but the way you have to make the decision making, there is a slight change. What is that slight change? Let's look at this. What is n here? This is your n. This is your n. Your sample is. What is your x bar? This is your x bar. What is your mu? This is your mu. So I want to calculate my z. What is my z? Z says x bar minus mu by s square root of n. So x bar is saying 34.5 minus 36 is my mu divided by my standard deviation is 4 days. 4 square root of 49. Can anyone tell me what will be the value of this? Okay. So let us assume this is coming as minus 2.62, just to avoid the calculation part. Because this is, and this then naturally, why it is minus? Based upon H1, this is a two-tail test. That means you are seeing on both the sides, this side and this side. Now your G value is coming as negative. Because your x bar is on the left hand side of this one. Since x bar is onto the left hand side of the mu, that means this is 36. Your x bar is 34.5. Since it is onto the left hand side, naturally your G value also will be negative. Okay. Now for Z 2.62, go and find out the Z value, your P value. Earlier you were finding the G value from the mu. This time in P value method, from the G value you are finding out the value. What is the G value here? I'm going to the table, G tables here. Look at this 2.62. This is 2.6. 2 is this third row. 2. This is what it is. So 0.496. This is one way here. 0.4956. This is Guys, this is one way. Please understand this. So what is the minus of this? Because it's two tail side, right? This is, if you look into the G table, it's only one side. So this is the value. What is the value here? This is 2, 11, 19, 9. Okay, it is 0.9912. But actually this minus 2.6 is falling it's going way beyond it. So this, your p value, sorry, your p value is nothing but 1 minus of this value, 0.9912. Whatever the value which you are getting out of here is your, this is 8, this is also 8. This is the p value. Okay, and now question here is, you will be calculating the p, you are comparing the p with respect to your alpha. What is your alpha here? Alpha here is 3%, which is nothing but 0.03. Now the question here, if the p is less than alpha, p is greater than alpha, p is equal to alpha. Three conditions you have. If p is less than alpha, 0.3, what is this? 0.0088 is less than 0.03. This is right? When P is low, null will blow. Remember, let me write it down. This is important, guys. P is less than alpha, that means P is low. When P is low, null will blow. Look at this rhyming. Low, blow, meaning reject H naught. When P is greater than alpha, that means P is high. Null means null hypothesis. Null will fly. Means accept H naught. When P equals to alpha, then it is purely driven by the business, and business decision is the final decision. Remember R. This is the P test, P method, guys. Okay. So I'll stop it here. Any question? If you are not understanding or it's not clear, please let me know. I will repeat this once again with one more example next Monday. I am 300% sure you followed over here. Only thing is, only one area you might have not followed is why I have subtracted 1 over here, 1 minus 0. This one, because this is what we figured out. Because G is always two sides, left hand, because it's a two side test. So it has to be two sides. But what we are looking, why we have subtracted it 1? Because this entire area under this curve is 1. So we are looking at from perspective of removing these areas, these rejected areas. That means I have to remove from 1 minus subtract whatever you have found it over here. That is why the value is 0.088. Hope this is, you understood this point. I am sure this is the only confusion which might be there in your mind. I'll pause for one more minute. Maybe, guys, I will not take more than 2 minutes. But is that clear to you? Because this is very important. Please respond. Ravi is clear about others. Okay, wonderful. Okay, so with that said, we are done with pretty much with the test of hypothesis. Now we will safely land into ANOVA. We will get into ANOVA. After the ANOVA, we will get into matrix algebra, a little bit of fundamentals of matrix algebra, and then I will execute the say. I will show you how you can do this in R programming. After that, I will say you are ready for machine learning. You are ready for machine learning. Then we will get into, I will take one example, then we will get into what is this regression, simple regression, multiple linear regression. There onwards, it goes. There you will be getting into logistic regression, then you will be getting into decision trees, then you will be getting into the random forest, then you will be getting into deep learning. The various aspects will come into the picture. Now, so SVM, support vector machine, then you will be getting into principal component analysis. They're all machine learning algorithms. Till if you understand these concepts, whatever we discussed so far, and we'll be discussing another 3-4 classes, then you will start understanding what is happening in data science, guys. That is why I call this course as a fundamentals of data science. But people teach this as a data science outside, and then they will take a lot of money. They'll charge you a lot of money. Even I charge a lot of money, guys. I teach the same subject to the US guys. I charge them the $55,000. Okay. So I for everything I give a lot of examples over there. That course will go for 5-6 months. It goes. Okay. So be aware. Be happy about this, which you got it right now at a throwaway price, whatever it is. But my intent is basically to make you understand this is what the original data science is. Don't believe outside what people are propaganda, doing whatever nonsense that they are doing in the market. Okay, catch you guys. Catch you on Monday.